Hi guys, welcome to Math Time with Spaghetti. This is Spaghetti. We're going to teach you a little bit today about some areas of different shapes. So, we're going to do a little activity with this. What you need to do first is get your graph paper and draw these four shapes on there. A square, a rectangle, a parallelogram, and a trapezoid, just like I've drawn here. You need to draw them the same size on your piece of graph paper. And then after that, what you're going to do, you're going to go ahead and cut them out. So just trace along those lines where you're going to draw your shapes, and then just cut along the lines and cut out each of your shapes. Great. So once you've done that, you should have all four of your shapes cut out. And so once you got them cut out, we're going to just look at them for a minute. So the first one we're going to look at is a rectangle. So the area of a rectangle is the easiest one to master. So if you can see, we've got our 4x3 rectangle here. So the base of it is 4 squares, and the height of it is 3 squares. So you could count this actually without calculating anything. You just count that this has got 12 squares in it, so the area is 12 squares. But if we had something way bigger and we didn't want to count all of them, an easy way to calculate is if we know how long the base is and how long the height is, we can just multiply them. So the base times the height equals the area of a rectangle. So this one, 4 times 3 equals 12. That's the area of this rectangle. So now it's your square. So we'll look at your square here, and your square is actually just a type of rectangle. And so since it's a specific type of rectangle, it's the same way, base times height, except for the base is going to be the same as the height since all four sides are the same. So you're just going to do base times height, which is the same as base squared or height squared. Either way, either of those three will work. So it's going to be 4 times 4, so that's going to be 16. So you can see that this is 16. So the next one we're going to look at is triangles. So when you have we're going to start with your square. So grab your square, and so a triangle, the formula for the area is actually very similar to that of a square. You're going to have 1/2 times base times height, because it's actually 1/2 of the area of a square that would have the same dimensions. So what we're going to do to prove that is we're going to go ahead and take your square, and you're just going to cut it in half diagonally from one corner to the other corner. Make sure you're hitting all those intersections of the squares. Make it straight. So now you'll see we have 2 triangles. So remember first we had a square, now we have 2 triangles, and if you put these on top of each other, you'll see these triangles are the exact same. So 2 of these triangles makes this square. So if this square was 16, that means that each of these triangles is going to be 8. So you can see this triangle has a base of 4, a height of 4, just like the square, because it's made from the square. And so the formula for the area of it is going to be 1/2 times base times height. So 1/2 times 4 times 4, which is 1/2 times 16, which is 8. So that's how you're going to do a square. You can see that it also works the same way with a rectangle, any rectangle, not just a square. So you can do the same thing, cut your rectangle. So you can go ahead and do this, cut your rectangle from corner to corner diagonally. You can see that these are a little bit different triangles than the square. They're not equilateral, but they go together, like this. And you can put them on top of each other, and you can see that they're the same thing. So since the rectangle was 4x3, and this area is 12, so each one of these triangles is going to be 4x3 divided by 6, divided by 2, which is 6. So each one of these is 6. Now, we're going to move on to a little more complicated one. Oops. The next one we're going to look at is a parallelogram. So for a parallelogram, what you're going to have is the formula for the area of parallelogram, funny enough, is base times height, just like a rectangle. And you might be looking at this and saying, how is that possible? It's got Just a really weird shape. So we're going to prove it. So take your scissors and your parallelogram that you cut out and go ahead and cut off the right side. So if you're looking just like that, you're going to cut off a triangle on the right side. So it's going to be like that. And you're going to take this triangle, you're going to move it over to the other side, and it should fit perfectly right there. And you'll see now we have a rectangle that is 2 by 4. And we know that area of a rectangle is base times height, so if it's 2 by 4, it's going to be an area 8 rectangle. So now if I put this back over here to look at the shape of the parallelogram, you're going to see the base, which is 4, right along here, base, which this top piece is actually 4 as well, the base, and then the height you're going to look at either right here or right here, and you see both those are 2. So that's where you find the height at inside the parallelogram. And so the base times height is going to be the same formula as the rectangle, because if you tear it apart and put it back together, it actually makes a rectangle. Now, we're going to look at a slightly even more complicated one. Right now what we're going to look at is a trapezoid. So this is a trapezoid, and the area of this trapezoid is going to be a little more complicated. So what you're going to see here is, if you actually break it down, is you've got 2 parts to this, and we're going to do very similar to what we did to this trapezoid, or to the parallelogram. We're going to go ahead and cut right here along that line, and now what you're going to see is this trapezoid is actually a triangle and a square, and we know how to get the area of both a triangle and a square, right? So this triangle is base 2, height 2. So 1/2 times base times height, so 1/2 times 2 times 2 is going to be 2, right? Which is 4 times 1/2. So the area of this triangle is going to be 2. And this square is actually, you can see it's an area 4, but if we wanted to calculate it, 2, 2, that's going to be 4. So the area of this trapezoid is actually 6, which you can see by doing that. And there's actually a formula we can write down for it. Okay, so the formula that we're going to write down for the area of a trapezoid is A plus B times H over 2. Now, we'll draw a trapezoid here so that we can see what these different things mean. So, sorry, I botched that a little bit, but, so we have this whole side here, that's B. This side up here is A, and if you look right here, that is going to be our H. Now, one other important thing that we're going to need to realize is that this little piece right here is going to be B minus A. So that's going to be B minus A, because this whole side is B and this little piece is A. So now, with that in mind, we can look, so A this side plus B this side times H over 2. Now, with that, remember when we cut it and we saw that it was actually a rectangle and a triangle. So we can just add those together. So we look at just the area of this rectangle right here. The base of that is A, right? This side is A, and then H. So the area of that is just going to be A times H. Then we can add it to the area of this triangle right here, right? Which, if you remember, is 1/2 base times height. Our base is going to be this piece right here, which is B minus A, times the height is also H. So 1/2 times base times height is going to be that. So now, if we do some simplifying on this, we're going to get back to this formula right here. So if you see B minus H, or B minus A times H right here, you can go ahead and distribute your H. So you got AH plus 1/2 BH minus AH. Now, you can also go ahead and move this 1/2. You can move it to the bottom here. Now, this AH, if you remember, if we multiply the top and the bottom of a fraction by the same number, it stays the same. So we can do 2AH over 2 plus BH minus AH over 2. Now, since these have the same denominator, we can go ahead and add them. So 2AH plus BH minus AH over 2. And you see these two terms right here, they're going to combine. These are like terms. So you've got 2AH minus 1AH is AH plus BH over 2. Then you can go ahead and take that H out of both of those. So you got H times A plus B over 2, which then you can rewrite as A plus B times H over 2, which, if you see, is the same as our formula up here. So you can see that this formula we can just use because it's a lot easier than finding both two different areas. But you can see that we get that by adding together the area of the square or the rectangle plus the area of the triangle. Okay, so let's review the rest of our terms. The area of our square, what was it? It was base times height. Good. The triangle is what? Yeah, it's 1/2 base times height. It's half of the square. The parallelogram was, okay, good. That's going to be base times height, the same as the rectangle, right? We cut off this triangle, moved to the other side. It was a rectangle. And then our trapezoid was A plus B times H over 2, which is kind of complicated, but remember, you can always just calculate it by the triangle plus the rectangle of the trapezoid. All right, guys, thanks for learning about areas of shapes with me today.